Hey y'all, happy Sunday and welcome to this week's live Q&A session. This is the portion of the show where we allow YouTube to send out notifications that we're going live. If you're watching this live Q&A on replay, please scrub ahead until this graphic disappears and the actual show begins. If you're watching live and you have any comments or questions, please go ahead and put them in the live chat. But for now, grab a beverage, sit back, and relax while the countdown timer does its thing. Then we'll get started. Happy Sunday, y'all. How's everybody doing? How's it going? Hope everybody is doing well. Some places spring has sprung. In other places, I think Mother Nature needs to go home because she's drunk. What can I say? Just another typical dreary. Although, as I looked out the door just a minute ago, the sun was peeking through the clouds, but it's a drainy, a rainy, drizzly, coldish day. So it's just kind of yeah. But you don't want to hear about that. Today, I was supposed to have released a video, an intro to the difference between setting your Z0 on the material surface versus the machine bed. And I ran a couple of projects, identical projects, one using material surface and one using machine bed. And I ran into an issue that I had to fix. And I didn't want to release that video until I fixed that issue. Then carved another project to make sure that the issue was fixed. So I didn't have time to do all that stuff before the video would have gone live this morning. So it'll be next week. And this is an introductory video. Gonna show you a few things to watch out for. Number one being axis calibration, particularly of the z-axis. In my case, if you have never calibrated your X, Y, or Z axis, I would highly recommend you do so, just to make sure that when you tell that bit to go down, for the sake of argument, 3/4 of an inch or 19 millimeters, it actually goes down that distance and doesn't go more or less. So, but we'll get into that more next week. And I can't tell you how to calibrate your machine unless you're using Mach 4 um, or Mach 3. And I think I've forgotten how to do it in Mach 3 because I did it like 5 years ago and haven't needed to touch it since. But you can do a search for your machine or your controller software and how to calibrate your machine, and then make sure that your settings are all correct and that your machine is actually moving the distances it is supposed to. And if you can't find instructions online, it's time to go to your machine manufacturer or your software publisher and ask them. That's what they're there for. Their tech support. That's their job. So that didn't come out. That'll come out next week. Here's hoping. Before I get too deep into it, I want to give a shout out to my friend Steve over here from Harneal Media. He is the sponsor of Mark Lindsay CNC.com, and I highly endorse him. I highly recommend him for all your website needs. He is the man, the myth, the legend, my only moderator, and I am very, very proud to call him a friend. And if you're looking to increase your web presence, start a web store to sell your CNC items, he's the first person I would contact. And when you're dealing with Steve, you are dealing with Steve. You're not dealing with some nameless, faceless person in a call center that you'll never make contact with again. You're dealing with Steve. There's a link to Harneal Media in every video on my channel, and he does a killer job. Believe me, I wouldn't say it if I didn't mean it. And thank you, Steve. Hi. Greg, the Snow Crusher says that would be the Z axis outside the USA. Yes, it would be the Z axis, but down here, Z is a name given to. I'm not going to go any further than that. Zed, Zeke, Jeb, you get my drift. Let's see. I've got a question or two up here. Let's get started. Let's see here. RB Woodwork wants to know, is there a way to keep the first pass from plunging to maximum depth on the first pass of a molding carve? I'm assuming you mean the molding tool path. I've tried, excuse me, I've tried changing directions and other things, no help. Um, let's go into the molding tool path. Um, and again, I believe that you're talking about the molding tool path. So let's go over here. Demo. And okay, yes, you just said yes. I'm in the middle of trying to set up my screen for sharing. And let's get over here into the molding tool path and let's see if there are any options here. You can use a larger area clearance tool. And with that larger area clearance tool, it will take the depth of cut that you have set for your that tool, the pass depth. That's what I was trying to think of. It will take that and clear out those areas. Let's see here. We do not have a choice between offset or raster because the molding tool path is carves different than a 3D standard 3D carve. Basically, from what I'm seeing here, your drive rail and profile have to have the same kind of. Have you? Okay, just a single tool. You might want to consider using a large area clearance tool, um, RB, um, just simply because not only will your uh, tool path go faster, it might actually go a little bit cleaner. Um, but and using a machining allowance, let's see, large area clearance tool. Let's select. I don't have any profiles or anything drawn. Let's go with, just for giggles, an 1/8 inch end mill with a pass depth of 1/8 of an inch. It can handle that. And do a machining allowance of uh, 0.03, just like I would for a 3D tool path. Um, and you can set it to just machine the flat regions or ramp the plunge, and you can ramp the plunge moves, which I normally do. But I don't know if that ramping is going to work with the tapered ball nose. Um, let's see. Molding is very small, 0.995. Well, that's an inch wide, so it's also going to be. That's also going to be. I'm thinking relatively deep. I do get where you're coming from. Um, I don't know. Maybe, and I don't know what type of ball nose you're planning on using. Um, I have the last ball nose I have selected here is a 1/8 inch tapered ball nose, which is actually pretty robust. I might do a first molding tool path with a, say, a 1/4 inch ball nose and just see how that works, and then come back and do another molding tool path with a with the smaller ball nose that you want to finish with. But right now, I can't see any way of starting from the shallow end. Now, ask you. Um, let me ask you this about that. Have you tried changing the start points to the shallower end of the molding and allowing that to plunge down? I guess what I'm getting at is, let me get out of this for a minute here. Close. And we'll go over here and I will draw a vector here to say here, space bar, and another one here to say right there, space bar, close, go into clip art and get a profile. Come on. Molding profiles. Here we go. And let's start with this one here. Now I'll come back to my molding profile and I'm going to use that as my drive rail and hold down shift, exceeds cut depth exceeds thickness. Ah, boy. Okay, let's go. Well, here, even though this exceeds the thickness, let's go ahead and grab these. You see what I'm getting at? The start point is down here. And you changing the start point to up here didn't make the tool path start along this edge. I know it didn't change the depth, but it didn't start the tool path up here along the top edge. It started it down below. Okay. Well, then, other than using, like I said, trying one a little bit smaller with, say, the 1/4 inch ball nose, and then coming back do another separate molding tool path with the taper ball nose of choice. That might be the only other way to do it. And again, I would consider using a larger area clearance tool because they tend to be more robust. I mean, you could get into this puppy and use a 1/4 inch end mill, and with that, it would clear most of that away. And in fact, that's what that's for. It would clear most of that away, leaving you a skin of about 30 thousandths to come back in and clean up with your ball nose. So there's a couple of different ways. I would try the 2 different ways and see which one previews the best. And then, as I say all the time, practice on some scrap, because it's better to chew up a $3 fence board than it is to chew up a $75 piece of maple. So, it's, at least that's been my experience. The bit size, it still wants to go down full depth on the first pass. Yeah, but a 1/4 inch end mill is a lot more resilient than a 16th inch tapered ball nose. That's my point. So even if it does go down that full first pass, you're going to have better luck with a clearance bit than you are with that. Because at the end of the day, even though it's a tapered ball nose, at the end of the day, the tip of that bit's still only a 1/16 inch bit, or 1/2 mil for those of you in metric. So, let's see here. Kurt Briggle says, can you show what the diameter versus the radius is on the bits, please? Okay, I was drawing this up when I saw your question come in, and I didn't have time to finish it. But the simple answer is the diameter is 1/2 of a circle. So if you're looking at the end of the bit like so, this is the diameter of the bit. So let's say it's a 6mm bit, 1/2 of that diameter, or that bit's diameter, is 6mm. It's going to be 6mm from this side to this side. The easy answer, the radius is half of the diameter. So I've got the same 6mm circle here. I have split the diameter in half. The radius around here is 3mm. So when you're talking about looking at the end of an end mill, you've got a 1/4 inch end mill. Let me go ahead back over here and go back into my drawing tab. Let's draw a rectangle here. And I'm going to move that because I should have put it down here. All right. I've got my rectangle here. I've got my bit, my 6mm bit. When I bring it up in here to try to machine out this corner, what I'm not going to be able to reach into this corner here is the radius of this bit. So that's the simple answer. The radius of the bit is, if you were to cut it into quarters, the radius is half of the diameter. Now, if you're talking about, let's say, a ball nose, you have a ball nose bit that's 1/4 inch quarter inch diameter ball nose bit. That's what I meant to do. And I'm going to cut that. This is what I didn't get finished setting up. And I'm going to delete this. And we'll go up here, and I'm just going to whip this together real quick. And you've got a 1/4 inch ball nose bit. Looking at it from the side, like so, that's what it looks like. But so it's going to carve a 1/4 inch diameter because the flutes run way up here. But this bottom radius is going to be 1/8 of an inch. So that's the difference between the diameter and the radius. The diameter from here to here may be 1/4 of an inch, but the radius from here around this way is 1/8 of an inch. So I hope that kind of clears that up. And I hope that was what you were asking. So let's see here. Let's go back in here. Okay, Jeff over at Woody One says, I do my epoxy inlays all in Corian, cutting board, serving trays, etc. Anyone know if they can be put in a dishwasher? I know that Corian can be put in a dishwasher by itself, although you need to either take it out before the dry cycle or turn off powered drying and just let it drip dry, because the heat from the heating element within the dishwasher can warp it. It happens. Let me put it that way. It depends upon the thickness, because remember, at the end of the day, Corian is basically plastic, and it is sometimes heat formed and bent. And I say that as a guy who used to work in solid surface countertop shops and cabinet shops and everything else. The heating element in the bottom of a dishwasher, when it comes to drying the dishwasher, is hot enough to where it can warp that Corian. Now, whether the epoxy is dishwasher safe or not, I would contact that epoxy's manufacturer and talk to them, explain what you want to do. And if you would, if you do that, if you wouldn't mind, please let me know what they say. Now, it's going to depend varying on the epoxy manufacturer, because Total Boat is different from West System, which is different from Epoxy, which is different from specialty resins. I mean, they're all slightly different formula, even though they may be about the same ingredients. It's also going to depend on which hardener you use. But I would be more concerned with the heat from that heating element in the dry cycle than anything else. So, and it's the same thing with any kind of an acrylic. You know, if you use if you use a opaque acrylic for something, and then for some reason put it in the dishwasher, that heating element can be enough to warp it. I mean, it may not, flop down like a 90-degree angle or something like that, but it'll be enough to warp, twist, bend, or what have you. So, uh, personally, a Corian cutting board with an epoxy inlay, take just a few seconds to hand wash it. I mean, especially if you do it right then and there. I do it all the time. Just a little soap and water on a rag underneath a running faucet, clean it up, dry it up, put it back. I mean, now if you let it sit for overnight, yeah, you're going to have an issue. But I don't know. I'd be a little bit nervous with putting it in the dishwasher, but contact the epoxies manufacturer. They would be the final arbiter on that. So let's see. Those were the only 3 questions that I have so far. Bob Frail says that he had a similar problem and could not resolve it with the molding toolpath options. So I just cut a profile first. There's a lot to that. Okay, let's see here. RB came back and said, I considered that, but really needed the part held in position to carve. It was 22 inches long on a 3-inch arc. Okay. Yeah. Now, obviously, you're going to be doing a profile cutout for the to cut the part out. So let me ask this about that. Create your toolpath. Okay, let me go back in to screen sharing here. We are working with it here. Let me turn off your comment, and let's I think I can get rid of all this now. Delete. And let's start with a line here and go to there. Close, go back into clip art and get a molding profile, and it doesn't matter which one it is. But what I'm going to do this time is I'm going to size this down. See, what size material do I have here? 3/4 inch. Okay. So I'm going to scale that down so I don't get errors. And I'm going to change the height to, let's see, 0.675, just for giggles. We'll apply that, close. All right, now let me check my start points here. Start point at the top, start point at this end. All right, come out of node editing. Let's go over and do a molding tool path. So there's my drive rail. There is my molding. We're doing okay here. Now, let me go ahead and take out the clearance tool and come down here, boundary offset. Let's see what I'm using an 1/8 inch tapered ball nose. It's not going to be very detailed, but let's go ahead and calculate that. You would think I would learn to change this, but no, what fun would that be? Okay, now I can tell by looking at my toolpath here, just by having it checked, I can tell that the start point is going to be up here. And that is, let me back out here, that is the shallow end of this cut. Okay. Now, you can, what I'm wondering, and I'm getting what Bob is talking about here. Let me uncheck that. We'll go close the preview, go back over here to the drawing tool path. If I draw a line, say here, that length is 3 inches. I don't want to go that far. Let's go 1.6 inches, close. And I bring that line down to there. Okay. Now, you know what I'm going to bump that up just a little bit. Let me bump that up slightly. And leave it there. Now, if I come over here, select that and make sure, do a profile toolpath. And this was being cut to 675. Let's go to 675. Use a 1/4 inch end mill. Make sure I'm going to the outside of this tool, line. And that's all I'm going to do. Calculate. Let's bump that up to the top. And then we preview this. It's going to create that profile that's the same thickness as our molding. Now, when this comes up here, when this bit comes up here to start this cut, it's already going to have a lot of that material eased out. In fact, it might also be a good idea to run another profile up along this edge here. And it doesn't have to be that deep. Just, I mean, for instance, this is 0.675. If you made it 1/2 inch, that's a little more than 1/8 of an inch for it to cut into. You get what I'm saying, RB. So yeah, let's go ahead and undo that and come back over here into the 2D view and do so, and I'll move this in a minute. I just want a 90-degree angle on that. And close. Shift, select that vector and join them. One closed vector, or one open vector rather. Close, select, and select again, and I'm going to bump it up to the top of this cut. And bump it out just slightly. Okay. Now come back over here, go back into the profile, select that. And let's make it go 0.6. Recalculate. Okay, now go back to a little bit better presentation here. And we'll preview that one first. Okay, do you see what I'm getting at there, RB? Okay. Bob is saying, exactly, Mark. I cut a profile on 3 edge to keep the part secure. Tapered ball node passes and then did a final profile to cut out. Yes, exactly. Exactly. Because now if I come in here and preview that, now obviously it didn't cut all the way down, but you see what I'm getting at. The tool is going to come in here. Come on. Tool is going to come in here and start its cut. It's not going to drive all the way down. So let me turn that off, and then we would do a separate profile to cut it out. Now, RB also says, I think I miss swapping the profile direction. Yeah, let me reset the preview and go back over here, close, swept profile. Let me click off of this, go into node editing, and I'm going to make this the start point, this deepest one here. Okay, now come out of node editing, select my drive rail, then select my profile vector, come down and calculate this one. It is, you see what I'm getting at? It is going to try to go to that deepest cut first. That's why I was wondering if you had tried swapping the start point on the profile and on the drive rail. Should start with your shallowest part of the cut. Also, what it did was it flipped that profile to where now it's cutting. If this was an arc, for instance, it's now cutting away from that. And let me turn that off and go back into my swept profile. We see it's going to start with the deepest and work its way to the shallowest. So, but that does give you a little pointer, even if you're using a 3D tool path. Now, John Thompson up here, up above, let me find, you were talking about, he may be better off to convert it to a 3D model and do a rough and finishing tool paths. If you have a spire, then yes, that is an option. But if you have VCarve, you can't create a 3D model. So that's not an option. And it doesn't matter whether it's VCarve Desktop or VCarve Pro. That's not an option. So he said, yeah, you couldn't swamp that because it had to fit in a door. Yeah, sometimes making things to fit into pre-existing, you know, you draw up a 3D model and it looks great, and now you want to carve that into the top of a jewelry box. If it don't fit that jewelry box, you in trouble. So, okay, let's see here. Matt over at Awesome Wood Thing says, what's the best cheap material that is super thin, 1/8 to 1/4 inch? I'd like to do a large multi-layered art 2 by 2 feet. Number one, inside or outside? Interior or exterior? If it's going to be inside, well, there's your problem. I was going to recommend plywood, not at the big box store. Not at the big box store. Go to your hardwood supplier. If you don't have a hardwood supplier, you probably have a cabinet shop. Talk to someone in there and see if they will add a couple of sheets to their next order, or add a sheet to their next order and you pay them for it, and they just piggyback it. You'd be amazed at what you can find as far as plywood is concerned. Another option you have would be, okay, it's going to be indoors. Another option you have is veneers. You can use MDF and then apply veneers to that MDF. That gets tricky if you're going to be doing inside. Let's say you cut out a circle in 1/4 inch MDF. Doing veneering the surface would be fine. Veneering the inside and outside edges of that circle may be problematic depending upon what you're doing. Yes, there are marine grade plywoods as well. The main difference between a marine grade plywood and something like an FAS cabinet grade plywood are the glues. And they use, I don't know if they're still using resorcinol glues. I know they've tried to cut down on formaldehyde glues in plywood, but they use a marine grade. But be prepared for sticker shock because marine grade plywood is pretty expensive. I would look into, I would go to the hardwood supplier and look into FAS grade plywood there. Is this going to be painted? Because if it's going to be painted, all bets are off. Use MDF. Um, if you can get, if you have a local sign shop or sign maker supply shop to you, or a plastics fabricator, you might check into gosh, I'm trying to think of what it's called now. One of the brand name is Sign Foam. It is uh, a it's a polyurethane foam, and I'm trying to think of what EPS I believe it is. No, that's polystyrene. HDU. That I couldn't. Whew, man, that one hurt. Check into HDU if it's going to be painted, because you can get a sheet of thin HDU, cut it out on the machine and paint it. You know, yeah. There's also close cell PVC. Thank you, Martin. Sintra is another brand name. There is Sintra. There is, oh my gosh, you name it. There are so many brand names. It's not even funny. But let's see. Russell Faraday says, I've not seen what I would call quality plywood for about 25 years, even marine ply. Well, I do tend to agree with you on that. However, everything is relative, and you are definitely going to get a better quality plywood from your hardwood supplier than you are from the big box store. Reload and Shoot has an excellent point. It's you could try 1/8 or 1/4 inch Baltic birch. Now, HDU, you're going to pay for it. Be prepared for a little bit of sticker shock there. Sticker shock there. And as Steve said, HDU is high density urethane. It's Sintra, Sign Foam, any of the others. It's pricey, but you get what you pay for. You can find PVC as well. Like I say, if you have a now, some folks can get PVC sheet at their local Home Depot. I am not one of those folks. I have yet to find that at Home Depot here on the West Coast. We have to go to the like a plastic supplier or a sign company supplier. Yes, everything costs money. You're absolutely right. But when you're talking about the difference between $75 for a sheet of plywood and $300 for a sheet of sign foam, that's 3/4 inch. Um, you know, yeah, it does make a difference. Yeah, there we go. Menards has PVC sheet if you're in the Midwest. On a related note, I had a comment to one of my monogram videos where the person said that they ended up cutting a monogram out of 12 by 12, and because they couldn't find 24 by 24 quarter-inch plywood, and wondered who my supplier was. And as I said, my supplier is my local hardwood retailer, not retailer, hardwood supply shop. In fact, I call them my offsite storage. They're free offsite storage, and I pay the storage fee when I go pick up material. That's how I justify it. And you'd be surprised at what kind of hardwood plywoods they carry and can order you. Now, mine can order me just about anything I want, depending upon how deep I want to dig into my pockets. But I can regularly go down there and I can get Baltic birch, I can get birch cabinet grade, I can get maple, I can get oak, I can get cherry. They will order walnut, ash, you name it. They will order it. So check with your hardwood supplier and see what they have, what they can get for you. That they might have a minimum order, they might not. But I bring home an 8-foot by 4-foot sheet, and I cut it the size of my table saw. So my first few years working at cabinet shops, that was my job, ripping sheets of plywood and cross-cutting them down to cabinet sides. So let's see. Peter Van Vliet has an excellent point here. PVC sheets are at Menards too. They have a smooth side and a flat side. No, excuse me. They have a smooth flat side, and the other side is a wood grained, which is nice for painting in a wood-like color. Yes. I can get trim pieces, but in PVC. But the widest I can get is like I want to say probably 4 inches wide, maybe 5 inches wide. So let's see here. Pat Riot wants to know, how's your sample MDF holding up? So far, just fine. That's because it's in the house. It stays in the house. However, the 3D project that I was going to put into this week's video were both carved out of the remaining 2 samples I got from Roseburg Timber Products. And they will be going outside here not too long from now. I've got to finish the projects, get them sanded and painted, assembled, and then hang them up on the fence outside, and we'll go from there. But so far, they are doing all right. So not much of a test, but let's see. RB says, "Oh, okay. Home Depot in Roseburg has PVC sheets in stock. How big?" I may have to check that out because I know my local store here doesn't have it, doesn't carry it, and won't. I've asked them, and I don't know why that is. But let's see. Yes, there are many, many sources of HDU, but again, Matt is looking for specifically what did he say? I'm going to say it wrong here. 2 feet by 2 feet, so 24 by 24. I don't know if they have any that large on Amazon. That's where you get into large sizes, starts getting expensive to ship. And you know how that goes. But I mean, there are a ton of options out there for you, Matt. Uh, yeah, used to be able to get PVC and ABS plastic sheets that was about 1/8 of an inch thick. And I used that in upholstery for door panels. automotive door panels, because it was nice and thin, didn't take a whole heck of a lot of uh, special tools for it or anything. You could heat it up with a heat gun. The PVC, you could heat up with a heat gun and kind of do a little bit of custom molding if you needed it to curve to a specific radius. Like if a car's door frame had a bit of a bow to it, you could heat it up with a heat gun and get it to keep that bow so it didn't oil can on you. Um, see, John Althofer says, I've contacted a local sign shop to buy small pieces of HDU. That's another option, Matt. You can, if you have a local sign maker that works with these materials, you can ask them about buying some of their stock. Let them know what you want to do and let them know that you're willing to buy. But if you're going to do for indoor art, another thing you might consider if you have a bandsaw is resawing your own and glue it up, and you have a CNC router, you can surface the entire thing. I mean, it'll take a while, but not too long, a couple of minutes. And then there you go. You've got your 1/4 inch to 1/8 inch panel, whichever you like. And then you're not limited as to what kind of material you can use. I mean, you can use anything from pallet wood to rosewood. So, I'm with A10 here. I mean, I reclaim a lot of lumber myself. In fact, this outdoor project that I'm doing for my wife that involves the 2 carvings I did last week are some parts of it are going to be that exterior grade MDF, and the other parts are going to be some reclaimed barnwood. So full size 2x12. Pretty cool. Reload and shoot says, traveling the country, I find that Home Depot stores vary in what they carry. A store in Washington might have something Georgia does not have, and vice versa. Can't figure it out. A lot of it has to do with transport. I'll give you an example. We cannot get the Columbia plywood, Columbia Products plywood that is sold by Home Depot, and I can't remember what it's called now to save me. It's one of their premium grades of plywood. I can't get it here. And it's mainly because it's shipped from way back east, and we've got plywood mills up and down the West Coast. So they buy from the local plywood suppliers here. And that's all. I can't remember what that brand of plywood that Home Depot sells, but I can't get it at my 2 local stores here. So, and let's see here. Been making all kinds of cool things lately. I love making and being creative. Hey, that's what this is all about. It's a cliche to say that the only limit is your imagination. Well, that may be true, but I would also expand on that to say your imagination as well as someone else's, because I'm not very good with coming up with my own designs, but I see something that somebody else has done and that'll spark an idea, and I'm like, oh, I know how I could incorporate that into something else. And that's where I go, you know. So I see people making cutting boards. Well, okay, fine. But now I want to do it my way. I'm not inventing anything. I'm not coming up with a design, but now I want to try it my way. So let's see. It looks like we are about out of. Okay, Roger Brown says check out Laser Supply Companies. Yes, another good one. Another good one. Online Metal. They have all kinds of sheets of plastic. Yes, there's that. Let's see here. Pure Bond. Thank you, John Thompson. Pure Bond. Yeah, we can't get Pure Bond plywood here. They buy from the local mills. So, it could be a combination of both, Kent. Um, my old eyes are pretty rotten, but remember, I'm only broadcasting in 720p. So, that could be part of it. And that's simply because I refuse to pay double the price of this streaming service for 1080p because nobody wants to see this in high def. Are you kidding me? You know, a lot of people turn me down to 480p as it is. Let's see here. Uh, it's it's interesting that you should ask that. Now, I'm not going to attempt to pronounce your name. Um, Let me do a little bit of looking because it was one, I can't remember exactly who did it. It was one of two people. I need to go check them both. Um, I have been, and the question is, how would you approach if you needed to carve a cabrio leg without 4 axis and only 2-sided machining? I need some solution. Maybe this will jar a memory in somebody else. Okay. Boom. There it is right there. Dennis Van Hoof. I couldn't remember if it was Dennis Van Hoof or Stephen Forsyth. Look up Dennis Van Hoof here on YouTube, and I will find a link to his video and put it down in the description of this video as soon as we're finished live here. So give me about 10 minutes and then check back to the description. He uses what he calls keyed indexing. And rather than try to give a long explanation, basically what he does is he cuts out a piece of material, he cuts a pocket, and then he glues some extra pieces on the end, puts his stock down, carves the top, turns it 90 degrees, carves one side, turns it 90 degrees, carves the back, turns it 90 degrees, and carves the other side. I have not personally done it, but Dennis, he's an absolute artist. He did about, I guess it was about a 2-foot tall column without a rotary, just, 4-sided machining basically. And this was not even double-sided. This was 4-sided. Uh, and the man, the myth, the legend, there he is right there. Steve jumped right onto it, and there's a link to his YouTube channel. I will find that video and I'll link it as soon as we get done here. But it was about I want to say about a 2-foot tall column. And Michael Keymont says, I'm using his idea to index 4th-axis machining via Aspire, and it actually works. Yeah, he is an absolute marvel. And if you're not subscribed to him, oh man, you're really doing yourself a disservice. Get over there and, in fact, I will put Stephen and Dennis uh, both in that category. I would Stephen Forsyth and Dennis Van Hoof. I would get over there and subscribe to both of their channels and binge watch. And when you see some of the things that Dennis does, your jaw is going to drop. We're talking about T-Rex skeletons. We're talking about the xenomorph from the movie Aliens, uh, with his little CNC router, and I think he's got a Shapeoko. I know he used to have a Shapeoko. Maybe he's got a bigger one now. So he's not using some big, super high-tech machine, or at least he wasn't. I don't know what he's got now. But, oh, man. Let's see. Vectric, Martin Pearson says Vectric has a four-sided machining tutorial from one of the user group meetings. I vaguely remember that, but check out Dennis Van Hoof's channel and you'll see exactly what I'm talking about. The guy is brilliant. So, let's see here. Yeah, the man, he works out of a little shed. He doesn't have a big shop. He does not have a big shop. So, but the guy is brilliant. You see some of the things he comes up with, and you're like, whoa. It'll literally make you just, I mean, are you kidding me? So, all right. We're a little over an hour in. Knock on wood, I will be able to get this video wrapped up and done and have it posted so that it goes live next Saturday. I'm going to do an explanation of what was going on and why my project, it didn't fail. I mean, it's still usable, but there was an unexpected twist at the end that I did not anticipate. And I wanted to have a wrap up and have a final answer as to why that happened before I posted the video. And I could not get that done before it went in time to go live this morning. So next week, it'll be an intro to setting Z0 on the material surface versus setting Z0 on the machine bed. Just an introduction. And we'll do a Q&A on that video next week. And let's see what else. That's about it. Yeah, that's about it for this week. Except for channel members. Tomorrow for the members only live stream at 5:30 Pacific, 8:30 Eastern, Brooks Martin brought up some really good points. So did Eitan Tal. But Brooks had a suggestion that I think has a lot of good merit. And if you missed last week with Dwayne Ruthig, number one, shame on you. Number two, get over there and check that out, because I will be referencing that a little bit tomorrow evening, but we're going to have a nice old discussion and get a lot more members involved in a lot more things. Don't mean to scare you, but yeah. If you don't know what I'm talking about and would like to check into becoming a channel member, click that join button down there by the subscribe button down there somewheres. They keep moving it versus whether you're on a PC or on a mobile device or your phone or whatever. So, but it's down there somewhere. Look for the join button. Click it. You're not joining. It's just going to pop up a panel. A video is going to play, tell you all about channel membership. So, first of all, I want to thank all my channel members and hope to see you guys tomorrow. Everybody else, I'll see you next week. And until then, making sure that was everything I wanted to talk about. That was everything I wanted to talk about. Y'all stay safe out there. The weather's been going crazy. I know the center of the country, including you, Steve, has really been nuts here lately. Y'all keep your head on a swivel because, yeah, wild times. Hope to see everybody back next weekend. And y'all, I'm serious. Take care.